Creating a class in Python. Everything in the Python programming language is an object. Therefore, everything belongs to a specific class. As we know, Python does not cater for all types of objects that we see in the real world. This is why we are not limited to only using the built-in data types, classes in Python. Just like functions, we are also allowed to create our own user-defined data types, classes. Our user-defined classes may be used by us to create new data structures, new data types, and much more. The general syntax for creating a class in Python is as follows. There are a few variations of class creation, but they are not too different, and we will also look at them in the near future. For now, this is the general way in which a new class data type will be created in Python. Class. Name of class. Define init, self, arguments, parameters, attributes within, methods within. On the next slide, I will explain what the various pieces of the block of code mean. Class, name of class, define init, self, arguments and parameters, attributes within, methods within. Class, the class keyword. Name of class, the name you would like to give to this new class, data type. Define, a compulsory function that is known as a constructor method. Self is a compulsory parameter. Self, the self keyword. This is compulsory to include for all new classes that are created in Python. Colon, a colon to denote a block of code and the creation of a new class. Attributes and methods that are associated to the new class and data type that is being modeled. Have a good look at the diagram on the previous two slides. Now, we shall examine in-depth explanations of the way in which we create a class in Python. So, looking at the previous slide, we see that in order to create a new class data type in Python, we need to make use of the built-in keyword class. This will let the Python compiler and interpreter know that the programmer is creating a new class because he or she would like to model a new object in Python. An object that is not already catered for by Python's built-in library of features. After the class keyword, we need to type the name we would like to give to our class. It is good practice to capitalize every new word in our class name, including the first word. Before we move on, a quick recap on three popular programming naming conventions. First, we have the popular camel notation. Here, the first letter of each new word in a variable name is capitalized, excluding the first word. Examples: total number of students, student marks, number of books, and so on. Next, we have Pascal notation. In this naming convention, we have to capitalize the first letter of each new word in the variable name, including the first word. Examples: car rental, student names, total number of payments made, and so on. We need to use this convention when we are naming our classes in Python. Next is snake notation. In this naming convention, we make use of all lowercase letters and we separate one word from the other using an underscore. I often make use of this when programming in my solo scripts. In my tutorials, I tend to use camel notation often. Examples of snake notation: total number of students, flower type, number of students, and so on. Excellent. Back to the topic of classes. So, as we said, first comes the class keyword, followed by the name of our class. We need to use Pascal notation when naming our class. After the name of our class comes a colon. The colon will denote a block of code in our program. This tells the compiler that any lines of code inside this block of code are a part of the class itself. So, we see a line of code that goes like this: define init, self, arguments, and parameters. Now you see, The above line of code is important. You will gain a better understanding when we create our own class and see it in action. But for now, just know that the above line of code, in particular the init, is known as our constructor method. There are actually two underscores before and after the word init. We will discuss more about the constructor method shortly. Afterwards, we see that we may define attributes and methods within our class. So now let us see exactly how a class is created in Python. To facilitate our understanding of classes in Python, we shall model books. Therefore, we will need a new class data type in Python because Python does not have a book data type. Our task is to model a book data type and create book objects for a library. So let's begin. Actually, before we begin, this is a good time for us to contrast the difference between the different classes in Python. In a standard scenario of Python programming, we could create books for a library like this. Book 1 name is equals to Diary of a Wimpy Kid. Book 1 author is equals to Jeff Kinney. Book 1 pages is equals to 210. Book 2 name Charlie and the Chocolate Factory. Book 2 author is equals to Roald Dahl. Book 2 pages is equals to 513. But now you see, we have an issue. We mentioned before that this approach is not permanent, it's not feasible. Yes, we are creating books, but these books do not belong to a book data type. Logically speaking, we are storing the name of the book, the author of the book, and the number of pages in the book. But these are all attributes of an actual book, and these attributes all belong to different classes. If only we could somehow wrap or encapsulate all these attributes in an actual book data type. That would be wonderful because it's basically like taking all your Lego pieces and storing them in one container instead of having them spread out on a carpet. So, to encapsulate all this information that is related to a book, don't have this information loosely lying around. Just create a new class data type in Python to model a book. The way in which we were creating books for a library on the previous slide, we required 3 variables for each book. So if we were to model 1000 books, we would end up with 3000 variables. There is no feasibility in that, no permanency. Permanency in a sense that we are storing all this information, yet our actual object does not even belong to a book data type. We are relying on users to implicitly understand that we have books here because they must surely be able to judge from the title of the books. So let's create a book class data type in Python to assist us with modeling a book for library. We will look at 3 attributes of a book in our example. Specifically, we will have attributes for the name of the book, title, the person who wrote the book, author, and the number of pages that make up the book, pages. We will now proceed to create a book data type in Python. First, we will make use of the class keyword as follows. Class. After the class keyword, we provide the name of the new class data type that we are creating. We would like to model a book object, therefore it is a book data type class, and we shall name the class book. Next, we will add a colon after the name of the class. The colon will denote a block of code, and all code that is indented inside this class will be a part of this class. Next, we need to code the compulsory constructor method inside the class. This is the init constructor method along with the self parameter. We would do so as follows. Class book, define init self. Now you see, the constructor method or constructor function allows us to pass values into it. It is exactly the same as we have learnt about functions in our previous tutorial. This constructor function will allow us to pass values into it, which can be assigned to variables and accessed at a later stage. Read the previous statement again carefully. The constructor function will allow us to pass values into it, which can be assigned to variables and accessed at a later stage. What this means is that our constructor method or constructor function will allow us to set parameters that will accept arguments for the attributes. So in our case, we would like to have modeled three attributes of our book. We will set names for these three parameters and pass them into the constructor function as follows. Class book, define init, self, parameter title, parameter author, parameter pages. So essentially what we are doing now is creating the template of the book data type or book object in Python. We are specifying to Python that every time a new book object is created, the programmer or user will need to provide three pieces of information, namely the title of the book, the author of the book, and the number of pages in the book. But now, we see that yes, we are passing the values of the book via the parameters of the constructor method or constructor function, but there is nothing to store or hold the values of this information. So we need to create variables to store this information. It is important to note that the way in which our variables are created within the constructor function of a class is different as compared to the standard or usual way in which we use to create variables. We create variables to store the values passed into the constructor method as follows. Class book, define init, self, parameter title, parameter author, parameter pages. Self.title is equal to parameter title. Self.author is equal to parameter author. Self.pages is equals to parameter pages. Look carefully at the above image. Our class template is getting built very well. You see, we have created the class using the class keyword. We have given the class a name, book. We have used the compulsory constructor method and have passed in the compulsory constructor argument, self. We wished to model three attributes of a book, therefore, we set up three parameters to pass the information to. When information is passed to the parameters, we required a technique in which we could store those values. It is at this point when we declared variables and set them equal to the corresponding parameter value. Now is the best time for us to understand the meaning and logic behind the self keyword. You see, the name of our variables are title, author, pages. The self keyword that we see before the variable names as well as in the constructor method init is referred to as the instance initiator. What this means is that every time an object of a class is created, in our case, every time a book object is created, we will be required to pass in three pieces of information each time to provide details for the book attributes. And the self keyword that we see before our variable names. For example, in the line of code that says self.title is equals to parameter title. In this line of code, self keyword is used before the variable name. Number 2, the name of the variable that is storing information about the title is called title. Number 3, the parameter that is supplying this variable with information is parameter title. Number 4, this means that the value the user passes into parameter title, which represents the name of the book, will be propagated into this class template and be stored in the variable called title. Number 5, the use of the self keyword next to the name of the variable is to denote and is called instance variables. This means that self.title is equals to parameter title, self.author is equals to parameter author, and self.pages is equals to parameter pages. These above variables are called our instance variables. What this means is that for every book object that is created and belongs to the book class, in that particular instance of the object creation, the values that we provide to the parameters will be stored in those instance variables. It is logical to think of self as a special variable in Python. Looking at our constructor function or constructor method, we see that self is the first parameter and it is one that is compulsory to include. However, when we create an object belonging to our class, we do not actually pass in a value to this parameter. Python does. When the Python compiler encounters the self keyword, Python is prompted to create a single individual object belonging to that specific class, and all the information that was passed to the constructor function for that specific instance will be stored in the instance variables of that object only, which means that we may create 1,000 separate objects belonging to the same class, but each time pieces of information pertaining to the parameters or attributes will differ, and each object will be stored separately in computer memory, and we will have the ability to access each object's attributes and information at our will. Now, back to our class creation. So, regarding the creation of our book class, we have this class book defined init self parameter title parameter author parameter pages. Self.title is equals to parameter title. Self.author is equals to parameter author. Self.pages is equals to parameter pages. Now, we have effectively created a simple template for a book data type or class in Python. Now let us proceed to create book objects in Python using our newly created book data type. Before we move on, I should mention that you can name your parameters and instance variables anything you like. I use the names I used to show and provide us with insight into how the information that you pass is propagated through the class constructor method. As a refresher, the class constructor method or constructor function tells us the data or information that must be passed to the template of the class in order to create an instance or object of the class. To create a new book object in our Python script, we simply have to make use of our book class data type template. Let's assume I would like to create a book object in Python. The book I would like to model is Diary of a Wimpy Kid by Jeff Kinney, and we assume the book has 213 pages. We create a book object as follows. Notice on the previous slide, we started creating a new book object with the name book1. You may name your object anything you like, and notice that when we specify is equals to book, Python automatically tells us the information that we need to fill. We need to provide 3 pieces of information for 3 parameters: parameter title, parameter author, and parameter pages. Here you have an object of typing the parameter name is equals to and the value, or simply passing in the values only in the respective order. So essentially what I mean is that this would work. Book 1 is equals to book Diary of a Wimpy Kid, comma Jeff Kinney, comma 213, or this would work. Book 1 is equals to book parameter title is equals to Diary of a Wimpy Kid, comma parameter author is equals to Jeff Kinney, comma parameter pages is equals to 213. And now, to ultimately check the data type of this book1 object, we proceed to call the built-in type function on this object, print type book1, and output will show as follows: class main book. And notice, we obtain output that the book1 object that we have created is of a book class, aka a book data type. Therefore, we are able to confidently conclude that we have a book data type present in our Python program. In the beginning of this tutorial, we were only storing information of a book in variables. Now, however, we have a book class in Python which allows us to create an actual book object. We have the ability to create as many book objects as we would like, tens, hundreds, thousands, as much as your RAM can hold. Let us create another book object. Book2 is equals to book Charlie and the Chocolate Factory, comma Roald Dahl, comma 513. You create any book that you like. I have created a book object called Charlie and the Chocolate Factory. And now, do you see how much easier it is for us to now create book objects in Python? Previously, in the beginning of the tutorial, we were only storing attributes of the book objects. Now, however, we are able to encapsulate all those attributes in a collective class object. And to make a book object, we simply create a new book object and provide three pieces of information. And to make this approach even more feasible, when we check the type of the object we create, it tells us that it belongs to a book class data type in Python, as compared to the beginning of the tutorial when the data type of the attributes were printed. Storing the information in attributes is just one part of working with classes and objects in Python. Since we are storing information about each object that belongs to the book class, surely there must be a way for us to access the information related to these interesting attributes. In fact, there is. You see, we simply need to call on the object that we would like to reference, followed by a dot or full stop, and then the name of the instance variable. The technique that is used to access the attributes of objects is called dot notation because of the use of a dot. We need to access the attributes via their instance variables. For example, print book1.title, print book1.author, print book1.pages, print book2.title, print book2.author, print book2.pages. I have included those two print statements to make output a little more readable. Output to the above code will show as follows. Note that we are accessing the attributes of each book object using the appropriate instant variable name. The self keyword ultimately allows each object of the same class to have the same attributes but a different value as seen in the output. Excellent.